Hello students, in the previous lecture we have discussed what is the asymptote and uh, they also discussed the method to find the rectangular asymptotes, that is asymptote parallel axis, horizontal asymptote as well as vertical asymptote. Now in this lecture we'll discuss two methods of finding the oblique asymptote. And first let us know what is oblique asymptote. Any asymptote which is neither parallel to x-axis nor parallel to y-axis is called oblique asymptote. So let's discuss the method. First method to find the oblique asymptote. Let the algebraic curve, rational algebraic curve is f of x y is equal to 0. And it can be put in the form of f y is equal to fx. Y is a function of x. Then the real linear equation y is equal to mx. If we can put this rational algebraic curve f of x equals 0 in the form of y is equal to fx, then the real linear equation y is equal to mx plus c will be an oblique asymptote to the given curve where m is equal to limit x approaches to infinity of y, put the value of y over here, divided by x, and find its limit x approaches to 0. If it is a finite number, that will be the slope of this asymptote. And c will be given by limit x to 0 of x approaches to 0, x approaches to 0 of this y minus mx. X equals 0 or x equals infinity? X approaches to x approaches to not 0 but infinity. X approaches to infinity. X approaches to infinity of this. X approaches to infinity of y minus mx. Put the value of y and m and c here. This is the asymptote, oblique asymptote to the rational algebraic of y. Y is equal to fx. Method second. Rule to find oblique asymptote to a rational algebraic curve. We'll find phi n x m and phi n minus 1 m and phi n minus 2 m and so on by putting x equal to 1 and y is equal to m in the rational algebraic curve, and there phi and m is the mth degree term, and phi n minus 1 m is the n minus 1 degree term, and phi minus 2 m is the n minus 2 degree term respectively of the this rational algebraic curve f of x y is equal to 0. This is the n degree term and 1 degree term. Suppose this is a third degree equation. So suppose this rational algebraic curve f of x y is a highest term is 3. So third degree term in the third term, if you put x equal to 1 and y equal to m, we will get phi 3m. If in the second terms of this rational algebraic curve, we put x equal to 1 and y equal to m, we will get phi 2m and phi 1m, so on to phi 0m. Put phi and m is equal to 0. Put the coefficient of highest degree term is equal to 0 and find all its roots. Let us know the roots are m1, m2, so on to m3 and so on. Are the real roots. Only real roots, not complex roots. We discuss with real roots. If m1 is not a repeated root of this phi n m, say it's a polynomial equation in m, then the corresponding value of c will be given by c into phi dash of n m, c into phi dash of phi derivative of phi is to m, also derivative phi is to m, mn, phi n is to m, plus phi n minus 1 m is to c. This equation will give the value, provided your if this is not a repeated root, if phi and phi m1 is not a repeated root of this phi and m, then phi and m1 is not equal to 0, because we know that phi and the common root of phi and m and phi dash and m will be the repeated root of phi and m. So It's not a repeated root, therefore this will be 0. This will give this equation will give the value of c. But if this phi and phi n dash derivative phi is to m at m1 is equal to 0, then m1 will be a repeated root of this. Then there will be no asymptote to the curve corresponding to the value m1 of m. Means there is no, we will get two asymptotes. Not only one, but we will get two asymptotes here. If this is a repeated root, common root of phi dash m and phi dash and m and phi and m will be the repeated root of phi mn. So if this is a repeated root occurs twice, repeated root occurs occurring twice, then the constant c will be given by c square factorial second derivative of phi n m raised to m plus c first order derivative of phi n m raised to m plus phi n minus 2 m is equal to 0. Here this root phi m1 is not repeated, it is not repeated three times. It's twice repeated, this is equal to 0. This is the two values of c, and we will get two asymptotes, that slope m1 and equal to m. Then the above equation will give us two values of c, and hence the two asymptotes, parallel asymptotes. Similarly, we can proceed if m1 is repeated 3, 4 and more times. If it is 3 times, it will be the value for value c cube upon 3 factorial, phi third derivative of nm plus c square root 2 factorial, phi second derivative of n minus 1m plus c phi dash of n minus 1m plus phi uh, n minus 2. So phi c into phi and n minus 2 m is equal plus phi n minus 3 is equal to n of m equal to 0. Take addition to this three values of c, so we'll get three asymptotes. If m1 is equal to 3 times, we'll get three parallel asymptotes to the question. Note. Similarly, we can find the asymptote for the other values of m. This could be m1, m2, and m3. We can find vertical asymptotes with the help of the above method. We can find vertical asymptotes because the value of c, we don't get value of c. For slope for the vertical asymptote will be infinity. Can't find, but we can find a horizontal asymptote by this method, but we can't find vertical asymptote. And rational algebraic curve of degree n cannot have more than n asymptotes. If you have a rational algebraic curve of degree n, so it cannot have more than it can have at the most n asymptotes. So let's find how to find asymptotes. Find all the asymptotes to the curve y is equal to x square plus 2x minus 1 upon x. Now, the equation of the curve is y is equal to this, multiply, simplify it. So, in order to find the rectangular asymptote, simplify it. Put the coefficient of highest power of x. Highest power is x square. X square is coefficient of this is 1. 1 can't be 0. No horizontal asymptote. Similarly, put the coefficient of highest power of y, that is x, minus x equal to 0. X equal to 0 is a y will act as a vertical asymptote. To find a oblique asymptote to the curve y, we are given the equation y is equal to fx. Y is equal to fx. So y is equal to fx it is. So let this y is equal to mx plus c will be act as a vertical asymptote of this curve. This. So where m is equal to limit x to infinity of y upon x. Put the value y divided by x, cancel them out, find the limit. Now this limit is finite. This is 0 of y upon x is 1, which is finite. This is slope and this is slope. Now we will find the c, limit x to infinity of y minus mx. So the value y function y is equal to fx minus mx. M is 1 value, so we get it minus mx 1x. Take LCM, simplify that, and then find the limit. First simplify that, then take the limit, which is 2, which is finite number. So therefore, as the oblique asymptote will be y is equal to mx plus c, m is 1, 1 x plus. Now this is the term. Now this algebraic equation, this rational algebraic curve is not in the form of y is equal to fx, so this is equal to f x equal to 0. Find all the simple this curve. So we have two methods. We can there are two ways. We'll discuss in this problem. Let this equation. And also do this curve x cube plus 2x square y minus xy square minus 2y cube plus 4y square plus 2xy plus y minus 1 equals 0. Equation of the curve is of awesome. Equation of the curve equation of the curve is of degree 3 I degree 3. Therefore equation first have at the most 3 asymptotes. Now the coefficient of highest power of x is x cube. As well as x cube. And coefficient of which is 1. 1 can't be 0. No horizontal. Similarly, coefficient of highest power of y is y cube here. And coefficient of minus 2. Minus 2 can't be 0. No vertical. Now in order to find the oblique asymptote, let us suppose that y is equal to x plus c is a oblique asymptote to the curve given by equation first. So substitute the value of y is equal to mx plus c. Make it in a polynomial in x. Make a polynomial in x, and you will get a substitute here. Simplify it, and after simplification, make it a polynomial of in x. So now our aim is to find 2. So this is equal to this polynomial is equal to 0. Which is equal to y equal to mx, and this equation because this equation is satisfied. Now, in order to find m and c, we need two equations. Now this is equal to 0 polynomial. Equate the coefficient of x cube is equal to 0 and x cube is equal to 0 and x is 0 and 0 because this is a polynomial 0x plus 0x square plus 0x cube plus 0x cube. So coefficient x cube is equal to 0 and coefficient x square is equal to 0. Two equation, two unknowns. We algebra two number of equation must be number of unknowns to find the unknowns. So we have two unknowns. We need two equations. So the coefficient of x cube and x square is equal to 0. So we got two equations. From the first equation, this equation, solve it for m. Independent of m, solve it for m. So after factorization, so after solving it for m, or we can also apply Harner method subdivision. Here, find the roots. So this is equal to we got the roots will be 1 minus 1 and minus half. They are the three distinct roots. And now substitute value c in the second equation. The value of m in the second equation, m equal to 1, m equal to minus 1, m equal to minus half, and we will get the three value c. Substitute then y is equal to, put the value of y is equal to m and c in y is equal to mx plus c, 1 by 1, and we will get three asymptotes in this curve. In this curve, three asymptotes in this curve. Or other way, otherwise we can solve it for c for three values, three asymptotes. Now the same problem can be solved by another method. Another solving the find the solution to this equation. Algebraic curve, put x equal to 1, y is equal to m in the equation. Now phi 3m, high degree is 3. So phi 3m is phi 3m here. This is same as the coefficient of x cube. The coefficient of this is coefficient x cube. This coefficient x cube. Phi 2m, phi 3m is the coefficient of x cube. When you put x equal to 1 and y equal to m, this is the coefficient x cube. And phi 2m is second degree term. Phi 3 means third degree term. Coefficient of third degree term. Phi 2m is this equation in m. Phi 3m is the coefficient of second degree term. And phi 1m is coefficient of positive term, and phi 0m is constant term. Coefficient of constant term. So put them. So this is equal to phi 3m, phi 2m, and you can find phi 1m and phi 0. So phi 3m derivative. Phi 3m immediate is equal to minus 2, minus 2m, 6m, and similarly now phi 3m you can get phi 1m also and phi 0m also. Coefficient of this is put into simplification. 30 term, put in 30 term m is equal to 1, x is 1, and y is equal to m. Term. Put secondary term, x is 1, y is equal to m. And first term, put y is equal to x is 1, x is equal to 1, y is equal to m. So phi 1 m will be m, and phi not m equal to how much? Is 0. Now put put phi 3m equal to 0. Phi 3m, same as we discussed the previous problem. Put phi 3m equal to 0. Coefficient of 30 term. That's it. Same equation. Same roots here. Region 1 and slope 3 slopes. Means you got this direction will have 3 asymptotes. As we have calculated the previous time. Yes, same. We put the coefficient of Hasley term. We put the coefficient of this Hasley term is 0. This is phi 3m. 0. Now here this is equal to this substitute value, I mean the coefficient of x square equal to 0 and b equal to c. Similarly, if we write c can be by the formula c will be minus 5 to m upon 5 3 dash 1 from this formula. That we discussed here. That we discussed in the so now c values. Now substitute the value. Now you have to find the c. This is same. This is same as this is the coefficient of x square when you put y is equal to mx. The coefficient of when you put y is equal to mx, this is same. So from c we will get c is equal to 5 to this. So two. Now say the difference this 1 over 1 and so 1 and minus 1 minus half and then just either they will 3. So versus with the root 1. So m is equal to 1, c comes out to 1. So this is some tool, oblique some tool. Similarly, when it's minus 1, c comes out to 1. So this is another simple. In this phi 3, phi 2 m upon phi 3 dash 1. We got this equation for this way. And similarly to the third, half, c comes out to be 0. So this is the third simple. So three simple. So both equations same, compare them and learn the method. Thoroughly, thank you very much.